Alright guys, this is part 2 of our review. We're going to do the 11, chapter 11B, or sorry, chapter 11A. And I'm going to do the odds. So number 1, the shape that this is a rectangle. So I'm going to look for the area of a rectangle formula, which is down here on the first page, length times width. My length is 20, my width is 7. So if area is length times width, that would be 20 times 7, which comes out to 140. Since my area is units squared, my units here are meters, so it'd be meters squared. Number 3, this would be a trapezoid because I only have one pair of parallel sides. Area of a trapezoid is on the back of the first page, which would be the height times base 1 plus base 2 divided by 2. So area equals height times base 1 plus base 2 divided by 2. When I look at my formula, or my picture, base 1 and base 2 are there. The height is from top to bottom directly where there's a right angle. So now I can plug directly in here. The height is 4, the base is 7, the other base is 10, and I'm going to add those together, multiply by 4, and divide by 2. 7 plus 10 is 17. So I want to calculate 4 times 17 divided by 2, which comes out to 34. Area is meters squared, so that would be my final answer. Number 5. Number 5 is a triangle. More specifically, it is a equilateral triangle because I have all equal sides. So if I look for equilateral triangle on my formula chart, it's on the back of the first page. S squared square root 3 over 4. S squared square root 3 over 4. The S stands for the side length, which I have is 8. So I would plug that in and do 8 squared radical 3 divided by 4. My calculator, I'm going to leave it and just do exact. So I type in 8 squared divided by 4, which comes out to 16 radical 3 meters squared. Number 7, this is another trapezoid. Okay, we just talked about area of a trapezoid is the height times base 1 plus base 2 divided by 2. Again, we have our bases, which in this case are 10 and 14. My height is where that right angle is from top to bottom. The height is not given. I need to find that. So when I look at this right triangle, I see not only is it a right triangle, where I could do Pythagorean theorem, special rights, or trig. The fact that they've given me a 60-degree angle tells me this is a 30, 60, 90. So I'm going to label my special numbers. I'll do that in a different color. So across from the 30 is x. Oh, sorry, 1. Across from the 60 is radical 3, and across from the 90 is 2. I write my number in underneath so that I can remember to divide. Divide in, which is 6, and then multiply out. So if I just care about the height would be 6 times radical 3, which is 6 radical 3. So now if I go back to my formula, our height is 6 radical 3. I'm going to multiply that by the bases added together, so 10 plus 14 divided by 2. I'm going to simplify that. That would be 6 radical 3 times 24 divided by 2. And what I'm going to calculate is 6 times 24 divided by 2, which comes out to 72 radical 3. And this would again be meters squared. So 72 radical 3 meters squared. Number 8, I'm not going to work for you, but my hint is that you need to either foil it or do the box. Okay, whichever method you're more familiar with. Going to number 9. Number 9 is a parallelogram. I know this because the opposite sides, I have 2 sets of parallel sides. The area of a parallelogram is on the first page, base times height. So area equals base times height. In my picture, base is 22, height has the right angle. So this time, again, the height is not given, so we're going to have to solve for it. This is a 30, 60, 90. So across from 30, I put 1. Across from 60, I put radical 3. Across from 90, I put 2. Divide to get in. 8 divided by 2 is 4. Multiply to get out. 4 times radical 3 is 4 radical 3. So my height is now 4 radical 3. My base is still 22. So I want 22 times 4, which comes out to 88 radical 3 meters squared. Number 11. Number 11 is a triangle. It is not equilateral, so I have to use the regular area of a triangle formula, which is base times height divided by 2. So area equals base times height divided by 2. This is an isosceles triangle because we have two congruent sides. So the formula for base of this triangle would be 24. The height has a right angle and is not drawn. So in my picture, I have base times height, which I don't know. So I need to find the height. Anytime you're missing a height, always look for the right triangle. The right triangle is now half of this picture. Okay, so if I'm using half of this picture, you can draw it a little higher if you want to. We have those side lengths, the height, and the 15. This bottom piece I can find because it's isosceles. I know that it's split equally into two pieces. Half of 24 is 12. So now I have 2 out of 3 sides of a right triangle, which tells me to use Pythagorean theorem, which is a squared plus b squared equals c squared. The only one you care about that is in your picture is c, which is the longest side, the hypotenuse. The order of a and b doesn't matter, so I'm just going to do h squared plus 12 squared equals 15 squared. I'm going to square each number. So this would be h squared plus 144 equals 225, and subtract 144 from both sides, which comes out to h squared equals 81. The only way to get rid of that squared is to square root. When I type in square root 81 in my calculator, I get a height of 9. So now I have the base of 24, a height of 9, and I can do base times height divided by 2. 24 times 9 divided by 2 comes out to 108 meters squared. Number 13 is another triangle. We still want to find the area. Area of a regular triangle we just talked about is base times height divided by 2. My base and my height always meet at a right angle, okay, which means this would be my base, this would be my height, and I have neither number. However, we do have a right triangle. We do have a 30-degree angle, which tells me this is a 30, 60, 90. If I label my special numbers, we would have across from the 30 is 1, across from the 60 is radical 3, across from the 90 is 2. I write it underneath so I can remember to divide to get in. 6 divided by 2 is 3. Multiply to get out. 3 times 1 gives me a height of 3. 3 times radical 3 gives me a base of 3 radical 3. So now I need to plug into the basic formula, base times height divided by 2, where my base is 3 radical 3, my height is 3 divided by 2. If I'm keeping this in simplest radical form, I'm just doing the outside numbers, so 3 times 3 divided by 2 would be 3 times 3 is 9 radical 3 divided by 2. I could leave my answer like this, or I could actually calculate what 9 divided by 2 is and get a 4.5 radical 3. So I would leave my answer 4.5 radical 3 units squared because we don't have units on this one. Oops. Number 15. 15 is another triangle. Area is what they want us to find, so we're still going to do area equals base times height divided by 2. Here in the picture, your base and your height still meet at a right angle. So here is my base. Here is my height. The height is 12. The base is not given. I need to find this missing piece right there. So back to triangle solving, we could use Pythagorean theorem, special rights, trig. This one, because they gave us no angles, I have to use Pythagorean theorem. A squared plus b squared equals c squared, where on this one, 13 is my c. So I would have x squared plus 12 squared equals 13 squared. Squaring each number gives me 144 and 169. And when I subtract 169 and 144, that gives me x squared equals 25. Didn't really give myself enough room here. If x squared equals 25, I can square root both sides, which gives me an x of 5. So really my base is 5. And now I'm going to plug into the area formula. So area equals base is 5, height is 12, divided by 2. 5 times 12 divided by 2 comes out to 30 meters squared. Number 17, we have two pairs of opposite sides parallel. This is a parallelogram. When I look at the area formula of a parallelogram, it's area equals base times height. In my picture, your base and your height meet at a right angle. Here's my base. Here's my height. Problem is, the base is valued x, the height is at 32, and I have no information in the right triangle to solve for the base or use that to help me in any way. However, they've given me the area. Area equals 832, so instead of putting A equals, I'm going to put 832 equals. Instead of B, my B is x, and instead of height, I'm going to put 32. Since this is x times 32, I'm going to cancel that out with division and get rid of the 32 on both sides. So 832 divided by 32 comes out to x equals 26, which means my base is 26 meters. Since we're going out of area and back to regular units, that would just be meters. Number 19, find the area of the composite figure below. Composite figure means two items or shapes put together. So that means I need to find the individual areas. So I have area 1 and area 2. The shape of area 1 is a triangle. So for area 1, I want area equals base times height divided by 2, the area of a triangle formula. Just looking at this triangle, the base and height of your triangle meet at a right angle. So here would be my base. Here would be my height. So the area of that triangle would be 3 times 4 divided by 2, which comes out to 6 meters squared. That's just the first portion of the area. The second portion, this shape, is a rectangle. Area of a rectangle is length times width. Well, the length and the width, or the base and the height, meet at a right angle. So here would be my base at 16, and my height would be this distance right here. Well, we don't have that distance. That's our h. And just looking at the rectangle, I can't figure out how to solve for it. But again, if you're ever missing a height, go to the right triangle. Back in this picture, that height also happens to be the hypotenuse of this right triangle. So I could do Pythagorean theorem, a squared plus b squared equals c squared, to find the height, which happens to be the c of that triangle. So I would do 3 squared plus 4 squared equals h squared. 3 squared is 9, 4 squared is 16, 9 plus 16 is 25, and when I square root, that gives me a height of 5. So really this piece right here is 5. So to find the area of that rectangle, I would do length 16 times width 5, which comes out to 80 meters squared. And again, if I want to find the area of the whole thing, I want the 6 meters of the first one plus the 80 meters of the second one, which comes out to 86 meters squared. There's my answer. Number 21. Given two similar parallelograms, what is the ratio of areas? Similar, anytime I see similar, I'm thinking of this bar chart. Okay, they've given me 5 and 8. Remember, this is old, this is new, it travels to the right unless I tell you otherwise. New over old would be 5 over 8, and that is a side ratio. Since the perimeter is made up of the sides, it's still 5 over 8, but to get the area ratio, I need to square it. 5 squared is 25, 8 squared is 64, so my ratio of areas is 25 over 64 is my answer. Since I'm just asking for the ratios, I just want the number directly out of the chart. If I was asking for a specific area or a specific perimeter, that means write a proportion like the next one will be. Number 23, sorry, it kind of bled through the highlighter. The rectangles below are similar. Similar rectangles tell me to do the SPA chart. And it says the perimeter of the smaller rectangle is 12. That should not be units squared, by the way. Find the perimeter of the larger rectangle. Okay, so if we're doing old to new and traveling this way, new over old for the side ratio would be 7 over 4. Perimeter is going to be the same. Area would be that ratio squared, which is 49 over 16. To figure out what proportion to set up, it depends on what I'm solving for. I'm solving for P, so I need to use the ratio of the perimeters, which would be 7 over 4. Okay, that was new over old, so I need to relate it to the actual perimeters that I'm looking for. New over old sides would be new over old x over 12. We have a proportion here that we can cross multiply. So 7 times 12 gives you 84. 4 times x gives you 4x, and those should be equal. So we're going to divide 84 by 4, which gives me an x of 21. That means that the perimeter of the bigger one is 21 meters. 21 is bigger than 12, so I know I did it right. Number 25. If the dimensions of a rectangle are made 4 times larger, how are perimeter and area affected? Think about it this way. Anytime you want to figure out how perimeter and area are affected, you want to use the SPA chart. So if the original dimensions are 4 times whatever it started with, so say 4 to 1, the perimeter would be the same as 4 times the amount, but the area would be that much squared. 4 squared is 16, 1 squared is 1. So I'm looking for a perimeter ratio that is saying to do 4 times the amount. New perimeter is 4 times larger. New perimeter is the same. I'm going to eliminate B because it's not the same. It's 4 times the amount. And C and D all say 4 times. Now I'm looking for an area that is 16 times. Area of 16 gives me only option D.